Lesson 79. Let's do the mental math. Go ahead and pause the movie, do your mental math, and then come back and see how you did. Here are the answers to the warm-up. This is a sum problem. We're finding the sum of these two numbers. They're both negative. So that means the answer is going to be negative because we're doing a sum. We're not multiplying. If these were multiplied together, this would be positive, right? But this is not a multiplication problem. So they both are negative. The answer should be negative, and we just add 25 to 15 and we get 40. All right, this one we move the decimal to the right 3 places. So that would make it 3,750. This one, if you notice, 100 divided by 10 is 10. So something divided by 10 is 25, or 25 times 10 equals 250. That's where we got the 250. Or if we just add a 0 to each of those, you would get what we have over here. Okay, estimate 15% of $11.95. Well, let's round that up to $12. And if we're going to do 15%, we first do 10% of $12, which is $1.20 because of that decimal place. So let me show you that. If we have $12, 10% of it would be $1.20. 5% is half of $1.20. So we're going to do 10% plus 5%. So what that would be, I'll write it over here, is $1.20 plus 60. 60 cents is half of $1.20. So this was 10%, this is 5%. Together they make 15%, so we get $1.80. Okay. With this one, we have milliliters to liters. Now, what we do is take this decimal, and liters happens to be the 3 places to the left of milliliters. So you go 1, 2, 3, 1.2 liters. Okay, this one, 20 is 4/5 of n. So if we saw this in a chart, 4 of the groups of 5 would make 20. So 4 is 20. So 5 times 4 is 20, and you multiply that by the 5. Now, if you did it like at a chart, remember we'd say, okay, so we know we've got this 1, 2, 3, 4, 5. Sorry, 1, 2, 3, 4, 5. Fast forward if you already got this. Okay, so 4/5 of it is 20. So you see how 20 was divided up into 4 boxes. So that means we've got 5 in each one. And so the whole thing is 25. All right, so here's your visual if these are still difficult for you. All right, let's launch into the lesson. We've got this idea of insufficient information and quantitative comparisons. Okay, so let's talk about insufficient information. Sometimes you'll get asked a question and you just simply don't have enough information to answer it. And that's an answer sometimes. That if you get a story problem and it looks like this, there's only going to be one answer to it, and I'll show you. Let's say we have a 10-pound bag of potatoes, costs $1.49. What is the average price of each potato? Now you might want to divide $1.49 by pounds, but it didn't say the average price of a pound of potatoes. It says what's the average price of each potato? Well, here's the big question for you. How many potatoes are in that bag, right? That's information we would need to know to answer that. How many potatoes are in the bag? That's $1.49. Then we could tell how much one potato is, but that answer is not there. So we would say this has insufficient, spell that correctly, insufficient info. Okay, and that's the actual answer to that story problem. Insufficient information. So that means we do not have enough information to answer that question. Okay, now the other idea is quantitative comparisons. That means we would need to know if something is greater than, equal to, or less than. Okay, So when we see this circle here, it usually means put a greater than or an equal to or a less than sign. Okay, so here's a situation. Let's say we have numbers, x and y are whole numbers. Okay, these are two whole numbers. Let's compare. Which one's bigger, or are they equal? Well, let's say x is -3 and y is 6. Well, in that case, y would be bigger. But what if x was 6 and y was -3? We just don't know. We don't have enough information. We would say this one has insufficient information. That's not always going to be the case there. Sometimes you're going to think it's insufficient information, but you're going to have to, it's a little bit of a brain teaser. Okay, so insufficient information is the answer to that. Okay, let's do this one. The number x is positive and y is negative. Compare. Well, if x is positive, y is negative, then x is going to be on the greater end of the number line, right? So we would write x is greater than y. If x is positive, y is negative, x is always going to be greater than y, okay? How about compare a to b? Oops. A to b, if we know that a minus b equals 0. A minus b equals 0. What does that tell us about a and b? Well, the equation doesn't give us enough information to determine the value of either number. We don't know if a is 6 and b is 5, or a is positive or b is negative. We don't know those, but we do know that their difference is 0. Okay, that means the difference between them is 0 on a number line. That means they must be the same number. They are equal. So the answer is a equals b. For example, if a was 6 and what would b have to be? 6 minus 6. It would have to be 6. What if a was -3? Let's just look at it. And -3 minus something equals 0. What would this have to be? Well, let's see. What if it was a +3? That would be -3 plus -3. That would give us a -6, and that does not equal 0. So they would both have to be negative. They have to be the same number. So you can always kind of try some options. So there's the answer to that one. And the rest is practice. That was kind of a quick one. Go ahead and do these, and then come back and check and see if you did them correctly. So pause the video and come back, or check in your answer key. Make sure you show me that you have corrected these, right? Okay. So this one, the difference between x and y is 1. There is one, but we don't know x minus y is 1. So we don't know. Let's just show you two things. This will help us if it's insufficient. Let's have x equal 6 and y equal 5. Now, is that true? 6 minus 5 equals 1. So that works, right? In that case, 6 is greater than 5. Okay, so we do know it works when x is greater than y, okay? But could there ever be the other way around? Let's show you a number line, okay? The difference between two numbers is 1, right? So let's just look at these. The difference between these two numbers is 1. So we did 6. So if we did 2 minus 1, x is 2, y is 1. Could we do x is 1 and y is 2? No, because once we go that way, the difference between them would be -1. Let me explain that. So if we had said x was 1 and y was 2, then the answer would be -1, and that wouldn't work. So if you try in all the ways and you keep coming back to basically x needs to be greater than y. If you think these are hard or confusing, that's okay, they are. It's actually kind of hard to teach as well, so don't worry about it. Okay, how about this one? M divided by n is 1. Okay, think about that. Are there any situations where you could take two numbers, they divide and make a 1? Well, That only works when these two happen to be the same, like 6/6, 1, 2 halves. So these are always, the numerator and denominator have to be the same in order for it to divide to make 1. Okay, so that's going to be m equals n. Okay, how about this one? A times b equals 1. Now what we have learned in the past is that basically we can get 1 by multiplying by a reciprocal. Or let's look at some options. How about, what if a and b equal 1? That would work. What if a equals 1/3 and b equals 3? That would equal 1. What if a is 3 and b is 1/3? That also equals 1. In all these cases, in this case, a equals b. In this case, a is less than b. And in this case, a is greater than b. So if all of these work, we do not have sufficient information to know which one is greater. So we're going to say insufficient info. Okay. For some reason this is bigger, like maybe your eyesight's going bad. I don't know why this got so large. Okay. The number x is not positive. Ooh, so x is not positive. That means x can be, 0. Let's just say x is not positive. So x is less than or equal to 0. That's what that sentence tells us. And y is not negative. So y is going to be greater than or equal to 0. Because it doesn't say either of them can't be 0. So let's compare them. Here's the problem though. Could they both be 0? Yes, so they could equal each other. Or if x is less than 0 and y is greater than 0, then x is going to be less than y. So these are actually the two possibilities. But we still don't know. Because what if they are 0? So that would be insufficient information. And that is it for the lesson.